Right. So we start. This is the last topic that we're going to study in this chapter, and the name of this topic is titration. Before going into titration, we need to have some basic clarity. Number one, tell me yes or no. Do you think you are clear with this concept called concentration? If you are clear, then say yes. If you are not, then we can once again review this. ये नहीं जानेंगे तो आगे वाला टॉपिक समझने में मुश्किल हो जाएगा. Are you clear on concentration? Okay. Concentration we have studied under two ways. One can be mass concentration, one can be molar concentration. If it is molar concentration, it is expressed in moles per dm cube. If it is mass concentration, then it is grams per dm cube. And to solve these things, we should know our basic conversions. That is 1 liter is equal to 1 dm cube, which is equal to 1000 cm cube. And so that you don't lose track of these things, it's the same thing if somebody studying in CBSE will study as moles per liter and will study this as grams per liter. Ultimately, concept is same, so that you know the exact idea. Okay? Then another thing that you should be clear with is the Avogadro's hypothesis or Avogadro's law. हालांकि टाइट्रेशन में इतना जरूरी नहीं पड़ेगा, फिर भी Avogadro's law says that 1 mole of a gas, this is typically for gas, at RTP, room temperature and pressure. And what is room temperature? We study 25 degrees centigrade and 1 atm pressure, occupies a volume of 24 dm cube, gives you a volume of 24 dm cube. Clear? This two you should know. Are all of you all fine with these two concepts? Then only we will understand what is titration. वरना titration में गड़बड़ी हो जाएगा. ठीक है? चलिए. Okay, fine. तो फिर इसको छोटा कर लेते हैं और इसको साइड में घुसा के रख देते हैं. इसको रख देते हैं साइड में. ठीक है? ये आपको जब पता ही है तो इसको यहाँ पे और छोटा करके रख. Right, ये रहने दो. Now titration. Titration means, before understanding titration, let's just get the basic. So here I will have two solutions. Solution A, it is a fight between solution A versus, okay, understand in the language I am explaining and then you read your textbook. It's a fight between solution A and solution B. Fight. So usually the fights are always between an acid and a base. Either of one can be acid and either of one can be base. Have you understood? So if you fight between an acid and base, you always know that all you are going to have is a neutralization which will take place. Neutralization. And this neutralization will actually give you something which is known as a neutral point. Right? Neutral point matlab, agar hum acid ko base ke saath, if we mix acid and base, we think that we should get water which is neutral. But madam, who told you that the same strength of acid and same strength of base are going to fight? We don't know that. But the normal concept tells us that if a similar strength of both of them fight, I am going to get it neutralized and a neutral point will be obtained. Now what is that neutral point? Beyond that, if I increase acid, the resulting solution will be acidic. If you increase base, it will become basic. Have you understood? Our job is to hunt this particular neutral point. Once this neutral point you have found this neutral point, your task of titration is over. Your task of titration is over. Now your question arises, sir, after doing this, what great thing on earth did I do? The great thing on earth that you're trying to do here is that either of solution A or solution B. Now, children, don't get me wrong that I'm trying to say for base or acid. I'm saying either. Either of these two solutions, I'm writing with this color, either this or this, one of them we will know, let's say it is this, the strength will be known. Strength is known. Again, once the strength is known, If the strength is known, then this solution will be called my standard solution. Standard solution. Got it? So the concept now is something like this, that I have developed a standard wrestler. This can be a robot. And all the wrestlers whom I am training, all the other wrestlers whom I am training, I will make those wrestlers fight with this particular wrestler, my standard wrestler. Iska strength pata hai. If you defeat this wrestler, you are stronger. If you can't, this you cannot, right? But in that manner, the whole object is to finally comment, or say find the strength of, say, A, solution A. Because children, don't think that only A can be the unknown one and B is the known. This is just an arbitrary example. Once this is known, I am supposed to comment on the strength of this. How will you comment on the strength of this? After achieving the neutral point. Do you understand? Or let me give you an example. This is a wrestler, my trained wrestler, who is my benchmark, standard. With him, I am bringing 5 children to fight with him. And the 5 children could pin this wrestler down. I have achieved my neutral point. Strength of the 5 children together is equal to the strength of this wrestler. In the next fight, when I went to class 8, 4 of my children could pin this one. So 4 of class 8 is equal to this. Are you understanding? This is the basic logic which we will go. That will be our logic. We will have a known solution. So a couple of 2 terms that we need to understand here is, what is a standard solution? A standard solution is that solution whose concentration is known prior to the activity of titration. Titration is the wrestling match, acid versus base, and our job is to get to the neutral point. अभी तो आपको बच्चा उच्चा इससे समझाएगा कि आप समझ लो. Like I said na, that the wrestler has to be pinned down. So in acid base mein, what is that pin down? We need to understand that. Then what is titration? Titration is the experiment of finding the strength of an unknown solution by titrating or allowing it to slowly pour over another solution till you reach a neutral point. And by that we will try to get it. Is the introductory story sufficiently understood? Can we get a little bit more chemistry now into it? Chalo, thoda sa chemistry karne ki koshish karte hain. Can I rub this off then? Okay. Let's try and rub this off. Now, I take a very, basic example, and I say that I have an acid called hydrochloric acid, aqueous, and this reacts with sodium hydroxide, which is, say, aqueous, and this gives me what? Water, liquid, plus NaCl, which is aqueous, right? This is a standard equation. In this equation, some things that you have assumed is that, now look at this. This is not concentrated HCl. Aqueous means आपने इसको पानी में बनाया है. पानी में acid घोला है. You have mixed acid in water. That means it is a solution. Who is the solute? HCl is the solute. Who is the solvent? Water is the solvent. Therefore, I should always now bring a concept here which is called molar concentration. That's the only way I'm going to understand the strength of this. I went to house of Ashmita and I went to house of, say, Sahasra. Both of them gave me tang to have. It was a hot day. Do you think that the concentration of tang in both the houses will be same? Maybe not. Maybe she gave a much more stronger tang. She had to take revenge on me. Hilao isko, hatta karo iska muh. So her molar concentration of her tang was more. And you gave me little bit fika pilao isko, bahut halla karta hai. So you gave me a tang whose molar concentration was less. Do you understand? That's the only way we can gauge between the 2 glasses of tang that I ate at 2 houses. So we will need something called molar concentration. Now I say that the standard way I read this equation is 1 mole of HCl reacts with 1 mole of NaOH to give you 1 mole of water and 1 mole of NaCl. Which means, no matter, now try to understand, no matter in how much water you are preparing your HCl, this is prepared in some drum. that solution's concentration should be what? 1 mole per dm cube. Then only it is known as 1 molar solution. Have you understood? अब ध्रुव क्या करता है? ध्रुव इसको कैसे बनाया? He does not have 1 dm cube vessel in his house. He has got half dm cube, that is 500 cubic centimeter. So Dhruv mixed half mole. Then also it is 1 mole. And Kirtan's minimum size is 10-liter vessel. So Kirtan has mixed 10 mole. Both the samples have the same molar concentration of 1 mole. Have you understood this or not? Did you understand this example of mine? All of you? Okay. That means if I take 1 spoon from Kirtan's bucket and if I take 1 spoon from Dhruv's bucket and if I taste them, suppose they are tang, the taste should be exactly same. Kirtan prepares it in 10 liter, Dhruv prepares it in half liter. हमें उससे कोई मतलब नहीं है. All we are interested is what is the molar concentration. Have you understood? Similarly, you prepared another 1 mole per dm cube of what? NaOH. So this is also 1 molar now. And this, I had given this job to whom? Kirtan. So Kirtan prepared it in like this, 10 moles per 10 liter or 10 dm cube, and Dhruv prepared this as 0.5. Okay, Dhruv prepared it as 0.5 per 500 cm cube. So he has also prepared 1 mole. Now you take equal volumes of both as a sample. कितना हुआ? 1 molar ही जा रहा है. If this is the sample, then we get NaCl and water will be mixed together. Now the solution we get here is again 1 molar. Have you understood? This is the standard equation. Do I need titration here? I don't need titration because both the strengths were known to me. The problem now that we will get is that ये लोग ये डेटा हमको नहीं देगा, ये छुपा के दे देगा, ये छुपा देगा, ये डेटा देगा मुझे, the standard. So this will be known as now my what? This will be known as my standard, and this becomes unknown. And what they will tell you? They will tell you 5 children from here could defeat him, neutralize kar diya. So they will tell you something like say 20 centimeter cube, say, okay, these are some data, say 20 centimeter of cube of this completely neutralize this. Now comment what was the strength. This is the problem that we are going to get. We are going to get the volume of the unknown one. So titration में क्या क्या होता है बेटा? Titration में strength of the known one is given to you, which is called standard, and volume, how many bachas could defeat it, how much volume could titrate it, that will be given to you. Based on that, you have to comment on the strength of this. So we need to little bit understand the process of titration also. जो कि यहाँ पे बोलेगा this is covered in chapter so and so, but let us understand how titration takes place. ठीक है? चलिए. So let's now try to understand what is titration all about. So like there are many ways you will be actually titrating one acid versus base. Okay. Both of these, since this is an experiment, we will take weak ones, weak acid and weak base. Like for example, one of the titration that we used to do, we used to titrate oxalic acid, and we should titrate it with KMnO4. This is a base. Oxalic acid is being titrated with KMnO4. Have you understood? Now KMnO4 is what in color, beta? Pink in color. Right? So we will have one device which is known as pipette. Pipette. How does a pipette look like? A pipette is typically like this. Okay. And there will be one mark out here. This mark will be written. Various pipettes are available. 25 centimeter cube, 20 centimeter cube pipette. It's a glass tube like this. Right? So I will have. Test your patience. I mean. So There will be a beaker, and in this beaker, the acid will be kept. Acid means it's a very weak organic acid. We don't use sulfuric acid and all. So my first job is to, and here the acid, which is my standard solution, will be kept. Means you know every parameter of this, how much molarity, what is the molarity of this solution, all is known to me. I will do what? I will pipette. You know how you pipette? You actually put the pipette inside it and you have to suck the acid. And you suck the acid to some level which is a little bit ahead out here. Very easily. You may say, sir, muh mein aa gaya, to a little bit, they'll make it in such a way that it will not bother you. And a pipette, you have a hole out here, right, on the other side. Pipette is like this. Suck it and you put your finger out here. And then slowly release your finger so that the excess liquid which was there is drained off and you can hold the liquid exactly at this place. Are you understanding? Suck liquid, so the liquid acid has gone here, and then slowly release it and bring it at the, this is called a meniscus. This is known as meniscus. So the pipette will now look like this, see. Like this, and there will be a mark out here. So I have sucked out, suck karke, ultimately up till here it is all acid. So how much of acid you took, and then you take one fresh beaker, and in that beaker you empty this. So this has now what? 25 centimeter cube of some known, say the molarity is known to you. What have you taken? Acid. Matlab, in our reaction, everything of this parameter is known. How much volume you took, right? And how much molar you took, that is done. Our next job is, the next apparatus that we use is called a burette. Burette. So burette is a device like this. It will have a clamp. Sorry, it will have a clamp, and the burette is a glass device like this, and bring the beaker right below it. This is what? This is my acid, standard solution. And this particular beaker, sorry, this burette, here I will fill my base. In your book, they might write acid here and base here. It doesn't mean, different type of. So what is my base out here? KMnO4, potassium permanganate, pink in color. And the burette has got a valve out here. Your job is to now stand and keep opening this valve. Okay. So as you keep opening the valve, what is going to drop from here? Yahan se kya girega beta? Pink drops will fall. What is the color of the acid? Colorless. One drop pink falls, and it is falling into an acid. Who is more stronger in the beaker? The acid is stronger. So the pink will immediately disappear. It's a beautiful experiment. The pink will disappear. Then you keep opening a little bit more. Dekhne ki zarurat nahi hai. And this burette is all graduated. Sorry. Okay. This burette has markings out here, all in centimeter cube. It can measure volume. So our friend Ashmita started her experiment with KMnO4 at this level. From this level, और वो धीरे धीरे खोल रहा है, तो KMnO4 level नीचे आता जाएगा. Then, and it has to be done very slowly. 2 drop, 3 drop, 4 drop, 5 drop, and sometimes you also shake it. Till the time it is losing color, the solution is still acid. You have not pinned it. ये हरा नहीं है अभी भी. एक point, then what she becomes restless. अगर जोर से खोल देता है, सर इतना देर कौन रोकेगा? Then it falls, and after sometimes you see it has become fully pink. No matter how much you're shaking it, ये pinky हो गया है. Is it titration? No. Now these fellows have मार के उसको खत्म कर दिया. We don't want that. We want equal lock-ons. So the teacher will deduct your marks at that stage. So she goes back and again does it. She has understood. ऐसा जल्दबाजी नहीं होता है. एक drop करते. Finally, she will come to a point when a pink drop falls and the entire solution becomes pink for some time, again becomes colorless. Please note that reading. next drop which she gives, it cannot be that accurate. The teacher always checks your judgment whether you know. The next drop which she allows to fall, the solution remains pink. Means ये basic हो गया है अभी. It is no more acidic. ये marking हमें नहीं चाहिए. I want this fellow to be neither acidic nor basic. That's why I told you, when it just became pink and it held its pink color for some time and again became colorless, that was my titration point. And that point, our friend Ashmita noted this and found this as V centimeter cube. That's what she needs. After that, the next drop sheet she released, she found that pink तो हुआ लेकिन pink गायब नहीं हो रहा है. Means आपने मार डाला उस standard को. That is not titration. Titration means lock-ons. Is the concept clear now? Right. We will not do this experiment, but in the problems that we are going to do here, all we will be given in these problems will be ये acid है ना, इसका molarity दिया रहेगा and इसका volume V1 दिया रहेगा. This volume will be given to you. And then you have to find out what strength of KMnO4 knocked off this acid. Now apply some common sense. If you are requiring more volume of KMnO4, that means originally your solution is weak. इसीलिए आपको ज़्यादा KMnO4 चाहिए उसको मारने के लिए. And if the solution of KMnO4 was molar wise strong, 3-4 drop देते ही pink हो जाएगा. Right? Common sense. If these fellows of grades 5 were really strong, 5 बच्चा जाके इसको मार देगा ना. लेकिन अगर ये लोग कमजोर है, then you need 14-15 kids to defeat this. That's all our problem about. Now this particular experiment that we did, we had a colorful base and a colorless acid. This is called auto indicator titration. Some titrations we may do in which the base is also colorless, the acid is also colorless. How do you get to know the titration point? You will add an indicator out here. And that indicator will be such that it responds only to the base. So as long as it is in acid, that indicator remains quiet. वो अपना रंग कब दिखाएगा? When it senses acid. So the moment this solution becomes colored, you have changed it to basic. So the point, that's why in titration what we do in say engineering and class 12 when we used to be very careful when we first saw the pink color. And sir used to say, first pink hold, Sir, pink gone, no problem. Note the reading. After that, if it becomes, sir, pink is not going away, our sir used to say, you idiot, you had to hold it before the first pink. Very interesting. और इस reading को 3-4 बार करके we get an average volume. And then is all our calculation to find out the volume. Your job here in this problem is to do that calculation. Is it clear? Shall we now go with the problem and take this? Okay. Have you understood? So what is titration? Titration is the process of allowing the volume of an unknown liquid to slowly fall over a standard solution and then titrate it and make it neutral, thereby measuring the volume that was consumed to find the strength of the unknown solution. So you always titrate with a benchmark. Standard के साथ unknown का fight, unknown का volume record कर लेंगे और फिर unknown का. How do you do it? With the general molar equation, standard equation. Bolo, anyone who has not understood this step, because based on this step only we will be doing our problem. समझ में आया बच्चा? One known guy will be there. Kirtan, have you understood the entire concept?
Yes.
One known solution will be there. It will be titrated with an unknown strength solution. Using an indicator, we will get a neutral point. We won't be that accurate. And once we get the neutral point, we record how much volume of unknown solution did we use. And then we use the standard equation, which you always use, HCl plus NaOH, this. And then apply unitary method. Bas, khatam, aur kya? Chalo, karte hain problem. Okay, आइए. Let's take one problem. Easy wala. And then we'll see some exam style questions also. That's the last part. Okay, let's take. So the question is a solution of hydrochloric acid. So let's see who are the actors. we have a solution of hydrochloric acid. That means HCl is in aqueous form. A solution of hydrochloric acid is titrated against a standard solution. So this one is my unknown, right? The unknown is titrated. First write the question. Is titrated against a standard. And what is my standard? Let me see the standard. The standard is sodium hydroxide solution. NaOH is my standard, right? So standard matlab kuch to data rehna padega. Okay. You found, now I'm writing the data in different color. You found that 20 centimeter cube means in this experiment, children, look here, this fellow was in the burette. He was pouring down, and this fellow was pipetted and then put in the beaker. 20 centimeter cube, matlab itna bachcha isko haraya. It will be that only. See, 20 centimeter cube acid neutralized 25.0 centimeter cube, 25.0 centimeter cube of 0.10 mole per dm cube NaOH solution. Now, children, pay attention. Okay. Now, this is the volume given to you, and this is the concentration or the strength given to you. Everything you have. That means, how did this experiment start? I first took NaOH, pipetted how much? 25 centimeter cube, and put it on a beaker and kept it. On that beaker, I have put another burette, and on that burette, I am having some given sample. I don't know the strength. मैंने burette को पूरा fill कर लिया, और burette को ऊपर से ऐसे खोल के some indicator I must have put, and then I'm observing that the neutral point was obtained when 20 centimeter cube of what? HCl was used up, right? They are asking me, what is the concentration of HCl? बोलो, पहले problem समझा कि नहीं बोलो. What is the concentration of HCl? Ashmita, did you understand the question now?
Yes.
Okay. Shall we? इसको छोटा करता हूं. Let's make it small, and let me keep it this side so that my data is there with me. So first of all, let me take the standard equation. What is the standard equation? HCl in aqueous reacts with how much, beta? NaOH aqueous, and gives you how much? NaCl aqueous. What is pollution? You can understand. Aqueous, right? What does this reaction tell me? Get your basics absolutely clear. 1 molar means 1 mole in 1 liter or 1 dm cube. 1 molar reacts with 1 molar to produce 1 molar. इससे हम एक चीज समझ लिया. We got to understand 1 molar HCl can knock off 1 molar NaOH straight away. Understood? Okay. Now let us try to find out that in our question, what is this data of HCl? Now look at this HCl. This HCl was prepared by a friend called Kirtan, and Kirtan prepared it in what manner? He took 1 dm cube. In 1 dm cube, how much is present? 0.10 moles are present. From here, our friend Sahasra has actually sampled out. How much she has sampled out? 25 centimeter cube. Now dm cube, centimeter cube, clash. This is same as Kirtan preparing this in 1000 cm cube. In 1000 cm cube, Kirtan had mixed how much? 0.10. 1 dm cube is 1000 cm cube. And if you still have some doubt, this is 1 liter also. Sahasra took how much? 25 centimeter cube. So in order to maintain the same consistency, 25 means what? 250 into 4 will give me 1000. 25 means into 40. So she took 1/40th of this. So how much of moles do you expect? 1/40th of this. Calculator मारने की जरूरत नहीं है. मारना है तो मारते हैं. चलिए मुझे बोलिए कितना moles होगा इसमें? How many moles will be there? This is exactly 1/40th. So make 1/40th of this. 1/40 into 0.1. 2.5 10 to the power minus 3, right? This is the sample created by Sahasra. Now tell me, if I could taste HCl, यहाँ से exponent and यहाँ से exponent, should I find a difference? No, I will not find a difference as long as consistency is same. Let's check the consistency. This is how much? 0.1 over 1000. Just do 0.1 over 1000. How much do you get? 1 into, throw loud bolo beta, 10 to the power minus 4. Just check the consistency here. 2.5 into 10 to the power minus 3. 2.5 into 10 to the power minus 3 divided by 25 for your calculator satisfaction. Check it. It's here on the board. Check it here. 2.5 or minus 3 divided by 25. Divided by 25. We are checking concentration. Others can also help. Don't sleep. 1 into 10 to the power minus 4. Are you now satisfied that the concentration is same? So if I would have taken 1 spoon sample from here and you take 1 spoon sample from here, and if you could taste them, they will taste the same. Clear hua? Have you understood this, what I did? ठीक है? तो फिर question once again. आ जाओ. What is this question? We have got a standard solution. What is my standard solution? NaOH. And what are the data given for NaOH? The data that are given for NaOH are 25 centimeter cube of, okay, it is found that this of acid 25 centimeter cube, 25 centimeter cube of 0.10 mole per dm cube. Beta ये जो है ना, this is the strength. This is the strength, or in other words, you can say this is the concentration, molar concentration of NaOH that you have got. Right? This is being, and this has been titrated with how much? With an HCl, and whose concentration is not known to me. I don't know the concentration. However, the same parameter for this is 20 centimeter cube. Is this understood? 20 centimeter cube of this could titrate this. Tell me in common sense, what do you think should be, not the figure. इसका 20 बच्चा इसके 25 बच्चे को हरा दिया. Who is stronger? HCl is stronger. So end of the day, the concentration of HCl should be more than 0.1. That's why you are able to kill 25 centimeter cube with 20. Is this thing working in your head? Right? ये answer आना पड़ेगा हमारा. ठीक है. Now you take the standard equation. What is the standard equation? The standard equation tells me that HCl as aqueous reacts with NaOH aqueous and gives you H2O liquid and NaCl aqueous. What we are more interested is on this side. And on this side, the equation is very simple. 1 mole reacts with 1 mole. 1 mole reacts with 1 mole. Right? So this data is known to me. This much data is known to me. Can I first find out how many moles of NaOH was there in my 25 centimeter cube? Let's find out this. So NaOH, the data tells me in 1000 cm cube, I had how much? 0.10 mole. Is this understood? 1000 cm cube, why? This dm cube is same as 1000 cm cube, na? But how much sample you took? 25 centimeter cube. Now calculate, use your calculator. So in 25 centimeter cube, how many moles were there? All of you try to do this calculation. In 25 centimeter cube, how many moles were there? 2.5 10 to the power minus 3 moles. All right. I am rewriting my equation, Sahasra, now. I'm not writing the right hand side, huh? I'm just keeping, because we are all interested on the left hand side. Tell me how many moles of HCl should it react with? Neutralize ho gaya hai. How many moles of HCl should be there? The same. Very good. The same. Very good. That's what I was looking for. Right? These moles and these moles reacted. बच्चा अभी मुझे ये बोलो, ये moles आया कहां से? In the 20 centimeter cube sample, they were present in this. Where is it? In this 20 centimeter cube, they were present. So, can we now find out the concentration of HCl? The concentration of HCl would be what? Number of moles divided by volume of solution. This should be in liters, or should be in dm cube, or it should be in 1000 centimeter cube, whatever it is. You have to ultimately give the answer in 1000 centimeter cube. So in 20 centimeter cube sample, you have to give the concentration. 20 centimeter cube. So our concentration, how do we get to our concentration now? Tell. ये निकालो, इसको छोटा करो. Okay. Let's make it small and keep it here. Sorry. Okay. Now, yes. The acid contains 2.5 into 10 to the power, how much? Minus 3 moles in 20 centimeter cube. Therefore, in 1000 centimeter cube, it contains, get me this figure. And 1000 centimeter cube is same as 1 dm cube, same as 1 liter. How much does it contain? 0.125. So initially, what was our strength? 0.1. We said, na, iska strength zyada hona padega. 0.1. Did you get a hangover of this? Ahiri, samajh mein aaya, bachcha? Where you have not understood, tell. We'll do this problem again and again till we don't understand. Want me to repeat the whole problem once again? I'm all fine. But we have to understand, because this will be a full marks problem. Fir se kare ek baar. There's nothing to be. Don't be. Don't be afraid. We'll do it again. Okay. Let's do it again. Have you understood basically what is titration? There will be a standard solution. In titration, we will have a standard solution and we will neutralize it with an unknown solution. Unknown means basically the concentration. And here the concentration will be known. And we have to neutralize. We have to find out the concentration. Finally, we have to comment on the concentration of this. And we will get to know how much volume reacted. What volume reacted, that will be given to us. Let's stage our problem. Our problem was that we titrated HCl aqueous against NaOH aqueous and we neutralized it. इसको हमने neutralize कर दिया था. We had neutralized it. Are we fine? In standard format, we say that such a neutralization between HCl and NaOH always happens as 1 mole can neutralize 1 mole. This is a truth. In other problem, they might give you H2SO4. If it is H2SO4, you will need 2 moles because there will be 2 hydrogen. Okay, so let's understand this. 1 mole neutralizes 1 mole. But this is when the solution has a concentration of 1 molar. But the world is not so good. They gave us the problem with this as how much? They said that the strength of this solution is 1.10 mole per dm cube, and you took 25 centimeter cube of this, right? And this one utilized was 20 centimeter cube. 20 centimeter cube of an unknown strength defeated 25 centimeter cube of this strength, right? Now, what is 0.1 mole? 0.1 mole means that if you have a vessel which is 1000 cm cube, then you have 0.10 moles of NaOH in it. But did you start with this vessel? No, you did not start with this vessel. You started with a much smaller vessel, which is only how much? 25 centimeter cube. Now, based on this ratio, find out how many moles should be here. Our first step. So step number one. Step one. I say 1000 cm cube NaOH contains how much? 0.10 moles. Sir, where did you get this data? Given to me. This is the strength. Right? Therefore, 1 cm cube NaOH contains 0.10. Ahiri, use the calculator parallelly with me. So many moles per cm cube. Agreed? Therefore, how much is my beaker size? 25. 25 centimeter cube NaOH contains 0.10 divided by 1000 into 25. Yes or no? So this is cm cube. Units, this is cm cube. Cm cube cancels. All you are left is mole. Can you, Ahiri, get this figure for me? 0.10 divided by 1000 multiplied by 25. How much is it? Your voice is not picking up. Now your mic is down. You're in Zoom. You need to set the. Ashmita, bol do. I think your mic setting is garbar.
2.5 into 10 to the power minus 3.
Okay, 2.5 into 10 to the power minus 3 moles. Clear? Have we understood? That means in my reaction, now I rub this part and I write NaOH, but it's not 1 mole. The fellow who is participating is 2.5 into 10 to the power minus 3 moles. Are we fine on this? Then we know the original 1 can defeat 1. So now tell me HCl ka kitna hona padega? How many moles of HCl should be here? Same 2.5 into 10 to the power minus 3. How much was the volume of HCl? 20 centimeter cube. Now you have to just comment on the strength. Now we have to find the strength of HCl, right? So let's find the strength of HCl. Let's make this smaller now. This is no more needed. So let's find the strength of HCl. Strength means you have to say, okay, you have to now see children, you have to comment on the strength, or in other words, you have to comment on the concentration. Means your final answer should be moles per dm cube, which is same as moles per 1000 cm cube. Hai na? Once you find this figure, you can, because 1000 cm cube is 1 dm cube. So what is the data we have? We have 20 centimeter cube HCl contains how much? Kirtan? 2.5 into 10 to the power negative 3 moles. Right? So in another way, we can write it as 2.5 into 10 to the power negative 3 moles are present in 20 centimeter cube. Right? Therefore, in 20 centimeter cube, so many mangoes cost 25 rupees. So in 1 rupee, how many mangoes should we get? In 1 centimeter cube, how much should you have? Tell me. It will be that by 20. See, basically, what you need to find out here is very simple. What you need to find out here is very simple. We have 20 centimeter cube contains 2.5 into 10 to the power minus 3 mole. All I want is, Ahiri, can you do this? If you cannot, tell me. Don't get ashamed or shy or anything. All I need to understand is 1000 centimeter cube contains how much? Try to do it. Pen Lona. Don't see the board. Try. Everyone try your book, and whoever can do this, tell me. Tell me. Okay. Bolo, koi problem nahi. Can I rub this portion? It's becoming too much hodgepodge. Or you still want to retain it? Yes. Tell it in a manner in which we can understand. Bolo. Sahasra.
Minus 3 by 20 into 5.
2.5 into 10 to the power minus 3 by 1000. How much is the answer you're getting? 0.125. So our unit should be correct. Okay. If you get confused, always play it with unit. Finally, your answer should come moles per cm cube or 1000 cm cube. This is same as moles per dm cube. Our answer should be this. That means whatever calculation you are doing, on top you should have what? The moles. What is the mole? 10 to the power minus 3. ये mole हो गया. And centimeter cube should be at the bottom. Yeah. So how much centimeter cube? 20 centimeter cube. And then into 1000. So ये पार्ट को मिटाते हैं. इसको करने से आपका आंसर क्या है जरा बोलो तो. What is the answer for this? No, just do this. Just do this. Just do this calculation. 1.25 10 to the power minus 4. What should be your unit? Moles per cm cube. See, I'm doing it in a very baby step so that you don't get confused. Moles per cm cube means 1 cm cube contains 1.25 into the, what is the English meaning of this? 1 cm cube. Confusion है 1 cm cube contains how much? 1.25 into 10 to the power minus 4. So 1000 cm cube contains 1.25 10 to the power minus 4 into 1000. 1000 is 10 to the power 3, which is equal to 1.25 into 10 to the power minus 1, which is equal to 0.1 moles per 1000 cm cube. Why did you bring this 1000? Because you have to finally give your answer in moles per dm cube. So what is the answer? 0.125 moles per dm cube. Yeah. Another way you can do this problem is that initially itself you convert cm cube to dm cube. Then whatever answer you're getting in dm cube only. That way also we can do. वैसा करके देखोगे वैसा भी सेम आंसर आएगा. आ जाओ वैसे करके देखते हैं. कभी भी कंफ्यूजन नहीं रखने का. Let's take this equation again. You have NaOH. What is the data they have given you? 0.10 moles per dm cube. And what is the volume they have taken, beta? Tell me the volume. 25 centimeter cube. First of all, convert 25 centimeter cube into dm cube. Then every answer will come in dm cube. Then ek bar mein. But this will be a little bit stiffer. How do you convert centimeter, milli, centi, deci? So 10 centimeters equals to 1 dm. So 1000 centimeter cube equals to 1 dm cube. How much do you have? You have 25 centimeter cube. So tell me how many dm cubes? 0.025. But the problem is that if you do by this, your calculation becomes much more complicated, because this solution is given in moles per dm cube. Then you have to convert HCl into dm cube. Then you have to convert the final. ज़्यादा मुश्किल होगा. Did you all get any hangover of this problem? एक और problem करके देखें. Just let's take one more problem. Same data, okay, same type. I'm giving you the equation H2SO4 sulfuric acid aqueous is reacting with 2NaOH. देखता हूँ ये problem कैसे करते हैं आप. 2NaOH aqueous, and obviously after this titration has happened, so what will we get? Sodium sulfate, Na2SO4 aqueous plus H2O. First see whether the equation is balanced or not. 2Na, Na2, SO4, SO4, H2 and 3, H2, H2SO4, 2 plus 1, 2 plus 2, 4. So you should get 2H2O. So oxygen is 2 and 4, 6. Oxygen is 2 and 4, 6. This is balanced. So what is the relation you get? What is the relation that you draw? What is the conclusion that you draw? You draw 1 mole of the acid will always get titrated with 2 moles of the base. Right? So shall we take our data? Our data is sulfuric acid solution. Now see, the acid is given to you. Now the acid is the standard one. This time acid is my standard. And let's take the data. So I have pipetted 25 centimeter cube, okay, and its strength is 0.2 moles per dm cube, and this could actually react with 10 centimeter cube. Find the concentration. Acha children, one more thing. Do you see something? This is given as 25.0, 3 significant figures, 1 significant figure, 2 significant figures. So usually your answer should always be in the one which is having the least significant figure. So your answer should be actually in 1. This is 1 significant. Zeros to the left is always insignificant. So answer should be in 1 significant figure, actually, if you try to do. So how do we proceed with this problem? Chalo, Sasra, you tell me, and calculator, someone will help us. Bolo, kaise karenge? What to do? All of us will do this problem together. No, this is, we can't do it like that. We have to first find out how many moles of acid are reacting. So how to find it? In dm cube, cm cube, that means 1000 cm cube. We are doing this calculation for H2SO4. This is our standard, right? Subdata, this is my standard. 1000 centimeter cube of HCl contains how much? 0.2 moles. First find out 25 centimeter cube contains how many moles? 25 is exactly 140th. So multiply this, divide this by 40. Tell me. 0.2 by 40. 5 into 10 to the power minus 3 moles. This is a very significant figure for you. That means in my reaction, how many HCl's are reacting? 5 into 10 to the power minus 3 moles. Bachcha, sabko ye data aaya hai. Don't try to do it fast. Okay, this. But these will react with how many? Can anybody tell me? They will react. Yes, very good. They will react with 10 into 10 to the power minus 3 moles. Because 1 reacts with 2. So 5 will react with double of this. So now we have to give its concentration. Bada easy ho gaya hai. So we say that the solution is such that in 10 centimeter cube, it contains how much? 10 into 10 to the power minus 3 moles. tell me in 1000 centimeter cube ये कितना moles contain करेगा? How many moles? In 1000 centimeter cube. So it's very easy. 10 into 10 to the power minus 3 divided by 10 into 1000 है ना? 10 ने 10 को काट लिया, 1000 1 mole per 1000 cm cube, or it is 1 mole per dm cube. 1 mole, 1 molar. So our answer should be 1 molar. Have you got 1 molar, Dhruv? Kirtan, is it clear now, beta?
Yes.
So try to do some exam-based question will be there, or take up questions from past papers, or take up question. I don't think you will get anything. You got anything different in exam. In fact, Ashmita had raised few queries on the day before the exam. That day we had not learned. So, beta, अभी clear हो आपको?
Yes, sir.
Standard दिया रहेगा. Standard से mole निकालो. This mole and then just fit it in the parent reaction. पिछले reaction में 1 reacted with 1, but in this reaction 1 reacts with 2. इसीलिए हमें मिला 5 मोल. 5 मोल कितने को किल करेगा? 10 मोल को. And 10 mole is in what? 10 centimeter. Therefore, in 1 centimeter cube we have got 1. 1000 centimeter cube. That's it. Unitary method, simple, nothing more than that. The whole problems hover around one thing. Do you know that 1 dm cube is 1000 cm cube? I think इससे बड़ा और कोई calculation नहीं था इस पूरे में. And the CBSE fellows will get this question as 1 liter is equal to 1000 cm cube. If you all are fine, I will give you certain problems. I also have these problems are from, if you want in our next class, we can devote one more class. School में तो भी कुछ नहीं हो रहा है. Let's have one more class. We will do CBSE grade 11 problems, which is exactly this chapter. Here you all are advanced than CBSE. So that's known as molar chemistry. वहाँ से तरह-तरह के problems करेंगे, like empirical formula, mass taking out. If we do 10 problems in our class, your concept will be completely clear. But yes, you should have your calculator and your periodic table with you. So we'll start with basics of molar mass, then finding out empirical mass, commenting on the formula of the product, then acid base, then concentration. 5-6 चीजें तो आपने सीखा है. Are you happy at the end? Have you understood? इसके कुछ problems करो. Then next class we can take up problems from our book also. ठीक है? Right. चलिए. So